Hi guys, we are going to work through our Unit 4 primarily with some videos, and so this video will cover topic 1, which I said yesterday was simplifying polynomial expressions, to be more specific. In Monday's class I asked you to work on the 5.1 worksheet, which had to do with monomial expressions. I'm going to go through a quick summary of the properties you needed to do the 5.1 worksheet today on the video, but I'm going to spend more of the time focusing on multiplying polynomials and operations with complex numbers. Those are your 5.2 and 5.9. The packet says that it's due Thursday, and that's true. You are having a quiz on Thursday. I want you to make sure the entire packet is done by Thursday, but we will be moving on to topic 2, so you want to make sure you get everything you can done as quickly as you can on 5.1, 5.2, and 5.9, topic 1. Okay, so we have these different properties that go with exponents that will allow us to simplify. Sorry, I see something up there. Never mind. Forget that a to the m that you see. That will allow us to simplify monomial expressions like you have on your section 5.1. Okay, so these are some rules that you learned in Algebra 1 and we're going to continue to use in Algebra 2. One of them is the product rule, where if you take a to the m times a to the n, that's equal to a to the m plus n. You're going to add those exponents when you have a like base that you're multiplying together. A power of a power, where you have one base, a to the m, and you're taking that to another power, you will, in that case, multiply your exponents, a to the m times n. If you have, this is a power of a product, and we did this yesterday, but I didn't write this rule specifically down. If you have a group that you're taking to a power, like in this case, a times b to the m power, then that's going to be a to the m times b to the m. Okay, I want you to make sure that you follow your order of operations, parentheses, simplifying within those first if possible. Then do any exponents. If you have whole groups to an exponent, you need to take care of that before you go and multiply by any number or expression that may be outside. Okay? The negative exponent property actually is twofold. A negative exponent, it really comes from the quotient of powers property that we'll see in a second, but it means that your base with the exponent is in the wrong spot in a fraction. Okay, so if you have a to the negative m, we want to clear out any negative exponents, only if exponents are negative. We can rewrite that as 1 over a to the positive m, and now we have rewritten a negative exponent as a positive exponent. This is going to be really important for us, this skill, as we get into calculus in a couple years. So we need to make sure that we get it now so that we can use it later. Okay? If you have a negative exponent that's in the denominator already here, again, that means that that a to the negative m shouldn't have been in the denominator. It should be in the numerator. So we write it as 1 over a to the negative m is really a to the positive m power over 1. We don't have to write the over 1, though. Okay, zero exponent property, anything to the 0 power is equal to 1. Quotient of powers. If you take a to the m and divide it by a to the n, this is related to the product of powers property. Instead of adding those like we did in the product, we're going to subtract m minus n. But you have to make sure that you do the numerator's exponent minus the denominators. Okay, subtraction is not commutative. We cannot switch that order. Okay. Now the power of a quotient, this is when we take a fraction to a power. That's going to be the numerator to the power and the denominator to the power. I'm seeing an error in what I've written here. That should be a to the m over b to the m. There should not have been an n there. Okay, let's get going. I'm not going over specific examples from 5.1. I feel that the properties that we just discussed on the previous page can help with that. I'm going to rather spend our time on 5.2 today, multiplying polynomial expressions. Some of these you'll see are just distribution using the properties to simplify that we've talked about already on the video. Some of them are FOIL. I want to make sure you remember that a problem where you take a binomial and you square it, please remember that you do need to FOIL those in order to get the correct answer. It's not like a monomial that we discussed previously where you just square each part. Okay? You have to actually square the whole binomial by multiplying it by itself. What I'm talking about is maybe a problem like if you had x minus 3 squared, you would actually have to think about that as x minus 3 times x minus 3. Okay? That's what I'm talking about. All right, let's talk about these, though, the ones where you have a binomial times a trinomial. FOIL only works if you have a binomial times a binomial. A binomial by a trinomial, we can't FOIL that. We don't have just a first, outer, inner, and last. So what we're going to do with these is we're going to go back to our old friend distribution. Okay? What we'll do is we are going to take the 4a that you see here, and we are going to distribute the 4a to every one of the terms in the second trinomial. Okay, so just the 4a, we're going to leave the plus 2 alone. So we're going to do 4a times 6a squared, 4a times negative a, and 4a times 2. And that's going to give us 24a cubed minus 4a squared plus 8a. Okay, now we could continue when we distribute the 2, which is going to be next. We could continue and write it all out to the side here. I instead like to drop down and line up the like terms. Let me show you what I mean. We're going to take 2 times 6a squared. That's going to give us 12a squared. So instead of writing it out to the side, I'm going to put the 12a squared underneath the 4a squared. Okay? All right, so we would distribute 2 times 6a squared, 2 times negative a, and 2 times 2 to give us what you see in red right here. Then it makes the like terms process, combining that, so much easier because everything's already lined up. Our final answer for 4a plus 2 times 6a squared minus a plus 2 is 24a cubed plus 8a squared when you take negative 4 plus 12 plus 6a and then plus 4. That is the product that you're looking for this answer. Practicing one more time. If you have a trinomial times a trinomial, same deal. We're going to distribute one at a time. First, the 6n squared through the second group to get 42n to the fourth plus 36n cubed minus 30n squared. Then we'll distribute the negative 6n. And I see my face is in the way. Let me see if I can move my face. Hopefully this moved for you. Okay, so negative 42n cubed, remember this is this negative 6n times all of these over here, minus 36n squared, oops, that should have been a plus 30n. Okay. All right, and that's going to change an answer here in a minute. And then we're going to distribute, finally, the negative 5 through all of them. Hopefully I didn't make any mistakes on this one. That would be negative 35n cubed minus 30n plus 25. Okay, so what you're going to see is we're going to add all of these up. We're going to have 42n to the fourth minus 6n cubed minus 101n squared if I did my arithmetic correctly. These are going to cross out, so we're not going to have anything there. Those cancel. And then plus 25 on the end. Okay, I'm going to get rid of this. Okay, that was because of my error that I had a minute ago. And again, there's our product. So this is just a distribution problem. We've got to move on to complex numbers now. Okay, so with complex numbers, a complex number we started to deal with in our last unit, we have a real part and we have an imaginary part of a complex number, a plus bi. A represents the real, b represents the imaginary. Anytime we add complex numbers, we should have our answer in this form, a real plus an imaginary. When we subtract, complex form. When we multiply, we should still get a complex number. And even when we divide, this will be after Christmas, we're still going to get a complex number. Okay, so I want you, when you add and subtract complex numbers, just treat them like you would any other variable. We're going to distribute the negative, and then we're going to combine our like terms. We're going to put the real part first, positive 2, and the imaginary part second, plus it's really 1i. We just don't have to put the 1. Adding and subtracting complex numbers, not a big deal. Multiplying complex numbers. Again, I'm going to have to move myself. Oh, I really hope this is moving. Otherwise, you guys are laughing at me right now with good reason. We're going to distribute the 4i through the negative 2 minus 8i. Okay, go ahead and write that down. Pause this if you need to. Okay. You should have negative 8i minus 32i squared. Ah, man, I'm having problems today. If you can tell, I'm in a rush. All right, that should have been a minus 32i squared right there. The big deal here is that I actually comes from the square root of negative 1. And of course, nothing is working right at the moment. I actually comes from the square root of negative 1. Okay? I told you a minute ago that all of our answers should be in a plus bi form. This is not a plus bi form because we have this I squared in there. So what you're going to do is whenever you get an I squared, I want you to rewrite that as I squared is equal to negative 1. Okay, so watch what I mean here. Instead of having plus 32i squared, we're going to take plus 32 times negative 1. This should really be a negative in here. I'm so mad at myself right now. Okay. So this is really a minus. And so a minus. And so our final answer is supposed to be positive 32 minus 8i, writing it with the real first and then the imaginary. Don't make this harder than it is, okay? For the second one, you're seeing two binomials multiplied. We're going to FOIL. 16 plus 4i minus 20i minus 5i squared. We're going to combine our like terms. And we're also going to take care of this I squared. Whenever you have I squared, we must change it to be negative 1. So 16 minus 16i, and then negative 5 times negative 1, which is really plus 5. So our real number answer is going to be 21 minus 16i. Okay, we also have, I'm going to try to squeeze this in, we also have some powers of I that you will see on your paper, okay? The powers of I are all based off of these two rules. I is the square root of negative 1. That means I squared is negative 1. I cubed is like taking I times I squared, so it's like taking I times negative 1. I to the 4th is like taking I squared times I squared, so -1 times -1 would be +1. I to the 5th is like taking I to the 4th times I, so 1 times I that should really just say I. I don't know why that did that. Anyway, there should just be an I in there. And then I to the 6th is going to match up with I squared, and that's going to be -1. Okay, so what we're going to do is match up these powers of I based on where they are to do with the power of 4. For instance, I to the 19th is actually 3 more than a power of 4. 16 is a power of 4. 19 is 3 more than that. So if we want to find the value of I to the 19th, we're going to go 3 more than a power of 4, which means that -I is equal to I to the 19th, or I to the 19th is equal to -I. This all goes back to the fact that to have a complex number, we don't want any more than I to the 1st. And so we're going to use these powers of I to rewrite. I to the 60th, I want you to think, I to the 60th, 60 is blank more than a power of 4. 60 actually is a power of 4. And so I to the 60th is going to match I to the 4th, which is +1. Okay. I to the 81st, again, 81 is 1 more than a power of 4. 1 more than a power of 4. And so 1 more than a power of 4 is going to put us not at 1, but at I. 1 more than a power of 4 is I. Okay, so I know that that was quick. I will definitely be here to answer some questions prior to you quizzing. That might mean for some of you I'll be here Wednesday, and for others of you it might mean Thursday. Unfortunately, I have a funeral to attend on Wednesday. Okay, so I'm sorry for the rush. This should help you. I want you to allow it to help you. You might have to go back and watch it again, okay, with some grace, because yes, I did have a couple of errors that I noticed along the way. You might need to go back and take some notes, but under no circumstances should I come in and you say, I didn't get any of it. That is not acceptable. Okay, 5-1, 5-2, 5-9, those 3 worksheets are your assignment, and yes, we will be quizzing on Thursday the 4th.